right, guys, go ahead and get out your probability notes from today, and we're going to go ahead and take some notes about compound events. Now, last year I know y'all went ahead and talked about probability, and so now we're going to talk about that there's two different types of events. There's independent and there's dependent. One thing I want you to do is when the outcome of one event does not influence the outcome of a second event. Okay, so that's what an independent event is. It means that the two things that you're comparing or you're finding the probability are different, whether like you're using a spinner and a cube, or whether you're talking about flipping two coins versus like flipping and doing two coins at the same time. Like the first time you're gonna flip two coins, the second time you also flip two coins. Because you're both flipping two coins, it's still an independent event. It doesn't change the second outcome. All right, now let's look at dependent event, which is going to be the opposite of that. It is when the outcome of one event does influence the outcome of a second event. Okay, so what this means, like if we're going back to like the coins, say if we flipped two coins and if we remove all the heads and we only use the coin that had flipped tails, that's going to change our second event. Because say if we flipped a heads and a tails the first time, we take away one head, we have one coin left. And so that's going to change the outcome of our second event. Now we're going to talk about complement of an event. And basically what this means is going to be kind of like the event's opposite. So what I want you to write is I want you to write that all outcomes that are not the event. Okay, so if I'm looking at the tails like we were doing today in class, like when we were flipping the coins, if I was trying to get you to find the probability of flipping heads, the complement of that would be tails. So how many times did it flip heads versus how many times it flipped tails? Now, one thing you do need to make note over here is that when we're talking about probability of an event, so like whether or not the coin flipped heads and its complement, so whether or not the coin flipped tails, always are going to add up to 1. So if we go back to like the quarter or the penny today, the percentage of flipping heads is going to be 1/2, and the percentage of it flipping, or the fraction of it flipping tails, is also going to be 1/2. So if I would add these two together, what do we get? We get 1. So 50% heads, 50% tails, 100% if we added them all together. Okay, so now let's look at example 1. Number 1 is saying we need to find the probability of tossing 2 number cubes and getting a 3 on each one. Okay, a couple things to underline. 2 number cubes. Okay, when I'm talking about number cubes is just like what we were tossing around today, and we're looking at a dice. Okay, so there's how many numbers are on a dice? There's going to be 6. Okay, the next thing I need to look at is the number 3. That's what my probability is. That's what I'm looking for. So basically, if I were to spin this dice or toss the dice, what's the chances of it getting on 3? How many 3s are on the cube? Just 1. Now, because they're making me do this twice, or I'm trying to figure out, I want to get 2 3s in a row, I have to write this twice. Okay, so my first time I roll, it's 1/6 of a chance of getting a 3. The second time I roll, it's another 1/6. Now, because I want it to be simultaneously, like I want this to happen one after the other, I want you to take note of the word and. And when we're reading these kind of questions, it means that we're going to end up multiplying. And the reason why we're multiplying is because it's when we actually want this to happen consecutively, it actually decreases our chance of it actually happening. So our chance of rolling a 3 twice decreases. It's smaller. So we're going to multiply these together. So when I multiply 1/6 by 1/6, I'm going to get 1/36. This is much smaller chance of happening than the original 1/6. Okay, now we're going to look at example number 2, which is talking about cards. If cards are drawn from the cards below, when we have this phrase, this P just stands for probability. It's just another way of saying it. Instead of actually spelling out the word, they just say P. And in parentheses is what you're trying to find the probability of. Okay, so if I'm looking at this, my probability is a J or a K. So my first thing I have to do is I need to add up all my cards. So if I were to count all my cards, okay, there's 7. Okay, I first have to figure out how many J's are there. So if I look at my cards, I can circle all my J's. So there's only 1. So it's 1/7 of a chance that if I'm gonna pull a card from the deck, I'm gonna get a J. So now I need to look at the K's. Okay, so if I still have all these cards out, there's only 1 K. Oops, sorry. So that would also be 1/7. Now when it has the keyword or means you're just going to add them. Because I can either draw a J or a K, and that's still going to be what I'm looking for. So I'm going to add 1/7 plus 1/7. When I do that, I'm going to get 2/7. Now sometimes when you get a fraction, you're going to be able to reduce it. This one I'm not going to be able to because it's 2/7. They're both prime. So 2/7 is my chances of getting a probability. Now if I were to talk about the complement of this, my complement would be, what if I chose anything other than the 2 that I'm looking for? So I would add up the rest, and that would be 5/7 would be my complement. Okay, that's saying that 5/7 is the chance that I'm not going to draw a J and I'm not going to, or a K. Okay, now I want you to take a second and kind of look at the now you try. So one is asking whether if you were to select a marble and then choose the second marble without replacing the first one, is this going to be an independent or a dependent event? Okay, number 2 is saying if I'm rolling a number cube and spinning a spinner, is this going to be independent or dependent? 3 is asking if a box contains a nickel, a penny, and a dime, find the probability of choosing first a dime and then without replacing the dime, choosing a penny. 4, you're going to look at the example 2 that we selected, and I want you to A, find the probability of an L or M or N, and B, find the probability of L or a vowel. The last one is if Mr. Winnicky and Mr. Webster have a coupon for a pizza with 1 topping, the choices of toppings are pepperoni, hamburger, sausage, onions, olives, bell peppers, and anchovies. If they chose at random, what is the probability that they both choose hamburger as a topping? Okay, and remember, what we're talking about here are all going to be theoretical and not experimental. What we did in class today, those are all experimental probabilities. These are going to be theoretical. All right, see you in class tomorrow. Make sure you finish all of this and then have it out on your desk first thing tomorrow morning. Thank you. Have a good day. Hello. All right, so these are all of my dogs and my children. So my question to you guys is, and there will be a surprise if you can write the answer to the back of your notes, is what would be the probability if I were to randomly choose one of my dogs and I were to choose a dog that had brown eyes? Okay, then question 2 for another surprise is what would be the probability of Kevin choosing a brown dog and Jackson choosing a brown dog? All right, so write the answers on the back of your notes and then submit them to me on tomorrow and you'll win something. Thank you.